When the wise man said, anything in excess is poison, maybe he was talking about the angle of attack. Before we answer questions like what is a stool or how is it caused, we should know a little about the normal functioning of an airplane wing. So, how do airplane wings work? We can think of airplane wings as airfoils. An airfoil can produce an upward force with high efficiency. This is thanks to the physics behind it. An airfoil, or in this case a wing, is made so that its upper surface allows easier wind flow compared to the lower surface. This results in a smoother airflow above. Now, smoother airflow means less air pressure, and less air pressure on the upper surface results in an upward lifting force. Quite simple if you think of it that way, isn't it? Now, let's talk about the same things again, but with more details this time. The starting point of an airfoil is called the leading edge. Meanwhile, the ending point of an airfoil is called the trailing edge. A straight line connecting these 2 points is called the chord. Along the chord comes the region of maximum thickness, where most of the lifting force is acting thanks to the lowest air pressure on the upper surface at this point. Going backward from the leading edge, there is an adverse pressure gradient, which causes the air to slow down and lose kinetic energy as it flows along the surface. The particles cannot continue to flow against a rising adverse pressure gradient. This leads to some particles being stuck in between the area of flowing air above the surface of the wing below. This is known as the separation point, and beyond it occurs a reversal of flow. Keeping up till now? Great, because there is one more thing you need to know about, and it is very important. The angle of attack. The angle between the chord line and the relative airflow is called the angle of attack. There are 2 main effects of increasing the angle of attack. There is some variation when trying to find out the ideal angle of attack for different planes, but one thing that's for sure is that increasing it too much causes stall. What is stall and how is it caused? During a stall, the wings are not able to generate adequate lift, and the plane starts to fall. There are a few common signs of an impeding or occurring stall in all planes, such as the aerodynamic buffeting, which means that the plane starts to vibrate. If a stall occurs in only one of the wings, it may lead to another situation called the spin. During a spin, only one of the wings stalls, and it causes the plane to roll due to the difference in the lifting forces on the wings. Another example of a very dangerous stall is the tip stall, which can cause wing drops and reduce the control over ailerons, which help control rolls. This type of stall is more common in airplanes with tapered or swept wings. Now, let's debunk a myth. A stall is not caused by high speeds or high altitudes. The angle at or beyond which a stall occurs is known as the critical angle of attack. Its numeric value is about 15 degrees, and it is also the only thing that can cause a stall. Therefore, a stall is a problem or complication of the angle of attack. What do you think can undo the effects of a stall? Tell us in the comments section below. Normally, recovering from a stall is not so complicated. There are 2 things that the pilot must do. 1. Push the nose of the plane down. 2. Roll the wings to an equal level. The combined effort of these 2 actions causes a plane to recover from a stall. Once the plane has recovered, the previous altitude and path can be reobtained quite easily. However, there are some situations in which recovering from a stall is not so simple. For example, recovering from a high-altitude stall is quite difficult. It is due to the lower density of air at high altitudes of, let's say, 35,000 feet. At such an altitude, the plane normally descends about 10,000 to 12,500 feet before recovering from a stall. Another thing that might be important to keep in mind is that the engines of many planes must be idled. This is because the thrust from the engines acts below the plane's center of gravity, resulting in an increased angle of attack. Throughout aviation history, stalls have caused many problems for pilots, including some of the worst plane crashes ever. Let's have a look at some of such incidents. On the 18th of June in 1972, the UK saw one of its greatest airplane crashes as British European Airways Flight 548 crashed soon after its departure from Heathrow. Right before the new year, on the 28th of December in 2014, Air Asia QZ8501 crashed into the Java Sea. This could have been avoided if the crew was even a little more responsible, as they were aware of the recurring problem in the Airbus A320. On the 25th of February in 2009, a Boeing 737-800 belonging to Turkish Airlines, Flight 1951, crashed on landing at Amsterdam. In 2005, West Caribbean Airlines' MD-82 crashed due to a stall at a height of 33,000 feet. On the 1st of June in 2009, an Airbus A330 belonging to Air France, Flight 447, stalled at a high altitude and crashed into the ocean. Many safety measures have been taken to avoid any further loss owing to stalls. Some of these include the following. A stick shaker is one of the most common devices of this sort. It starts to shake the controls using a motor to notify the pilot that a stall is on its way. The angle of attack vane, which is attached to the fuselage of many airplanes, is used to register the angle of attack into the system at any time. Stick pushers are used to physically push the controls in case the airplane comes very close to a stall. By international standards, a stall warning system must notify the pilot at least 5 knots before the reference stall speed is achieved. Many changes have been made in the designs of the newer airplanes that would lead to a delayed stall after it is inevitable. These include things like adjusting the attachment of wings to the airframe such that it reduces a chance of tip stalls, using stall strips to cause the roots to stall faster than the tips, vortex generators that make it easier to fight the adverse pressure gradient. Using engine strakes also delays stalls. Pilots are also trained to recognize conditions signaling that a stall is approaching and control it. Thanks for watching the video till the end. Did you find the video to be informative and easy to understand? If so, let us know in the comment section below what topics we should cover in our future videos. Don't forget to like the video and subscribe to the channel as well. As always, see you all in the next one.